Go to the downtown stuff going on, some of y'all? Yeah? I saw some of you. I did see some of you. And some of you kind of look at me from afar and kind of turn your vision elsewhere. Okay, that's fine. I'm not going to give you any math stuff on the street. Come on now. Anyways, it was pretty good. I liked the first event of the year, you know what I'm saying? Good outing. It was nice weather. Still nice weather. Nice and cold. I like that. I was telling my wife, here come the earthquakes. Let's go. Bring them. You know what I'm saying? Because of the tectonic plates and all that. You know? And warm-up number 37 is on the screen. If you notice, I'm bringing back number 1, which is rational equation, and see if you remember how to solve those. If not, I'll go over it. I mean, I'm going to go over the whole thing, but see if you can go ahead of me. Number 2 is factor, same as number 3. Number 4, you solve for y, and then it says use the domain -2, 0, 1, and we know how to do that. But then it says graph. Let's see if you remember how to graph. And number 5, it says I gave my dog some blocks as toys to play with, and he started stacking them as follows. Bam! Sketch the figure number 6. All right, I'll give you guys some time. Copy and feels like summer. All right, here we go. Just for the sake of time, I'm going to go over the warm-up, being that it's Monday. Here goes for number 1. Let me make some space here. Now, by now, you should remember that whenever we have fractions all the way, we need to get rid of the fractions, right? So we multiply the entire equation by what? Remind your neighbor. What by what? By the common denominator, which is what? 12, yes? And I'm going to write it 12 over 1 since I'm multiplying fractions. So 12 times 1, 12 times 2, 12 times 5, and 1 times all these. So this is 12 over 2x, 24 over 3, and 60 over 12. You remember that, yeah? Yes, Mr. Q. 12 divided by 2 is 6x. 24 divided by 3 is 8. 60 divided by 12 is 5. And then we solve. Line down the equal sign. We need to leave x by itself. Minus 8 minus 8. 6x equals -3. And lastly, divide by 6. X equals -3/6, or 1/3. Ooh. Oh yeah, we got this. Number 2. By now you should know the factors of number 2. Tell your neighbor your factors. See what they got. Make sure they have the same thing. Factors from number 2. All right, good. Factors. X plus 1 and x plus 2. Hands if you got that. That is correct. Number 3, factor. Is there a GCF for 4 and 49? No. But since it's a subtraction and it's a squared, let's see if we can take the square root of each term. Square root of 4x squared. That's 2x and 2x. Yes? Square root of 49. +7 and -7. That is correct. Ooh-wee. We good, yeah? So far so good. The only thing that I'm trying to bring back is these, trying to retrieve them from your long-term memory. All right? Let's go to number 4. Solve for y. Let me make some space once again. So, I need to leave y by itself, so I subtract 15x from each side. We end up with 5y equals -15x plus 10. From there, we divide by 5 both sides. We end up with y equals -3x plus 2. So far, so good, yeah? All right. And do we know how to use this domain with that equation? Yes, Mr. Q. However, today, look up, I'm going to make a table. Here it goes. x, y. And for the domain, I'm going to write what? Negative 2, 0, and 1. Negative 2, 0, and 1. Do that with me, please. The domain. So now I'm going to do everything right now in my noodle just to go a little bit faster. You guys already know how to do the next part, which is you write the equation, negative 3, open parentheses for x plus 2, and we use each of these values. Is that correct? All right, so here we go. Negative 2. If I substitute negative 2 here, what is negative 2 times negative 3? 6 plus 2, 8. Let me move this up for those of you in the back. There it is. Next one. 0. What is negative 3 times 0? Plus 2? 2. Not 8? Oh, negative 2 times negative 3 is positive 6, plus 2, that is 8. All right? And last but not least, 1. What is 1 times negative 3? Negative 3 plus 2, negative 1. All right, let's graph this. You're like, oh, yeah, Mr. Q, I love graphing. I know, right? Let's go. The word of the year is called what? Graphing, and we're about to get into transformations not too soon from now. This is our x, this is our y, and we're going to graph these points right here. So I need to, all the way from negative 2 to positive 1 of x, so I'm going to go 1, 2, 3, 1, 2, 3. And I need from 8 of y all the way to negative 1, so I go 1, 2, 3, 4, 5, 6, 7, 8 to negative 1. All right, so let's plot the first one, negative 2, 8, negative 2. This is negative 1, negative 2, and positive 8, which is up here. 0, 2, 0, 2, and 1, negative 1. And we graph our line going through those points. Ooh, let's go. Is it coming back, some of you? Yeah? You know, I was telling some of my other class, I'm like, guys, they should have made Monday like Energy Monday instead of Comfy Monday. As it is, sometimes you guys get here on Mondays and it's, you know what I'm saying? It's one of those days that you're like, kind of like, oh, Mario. All right. With that said, look up, please. Number 5. My dog got a figure. He got the little block, left it there. That's figure 1. Figure 2. Figure 3. Dot, dot, dot. I need figure 6. How many blocks do we need for figure 6? Talk it with your neighbor. How many blocks for figure 6? Like Mario's got it, very good Mario. And then Gio's got it, very good Gio. So look up, here, let me give you a hint. Figure 1, figure 2, figure 3. All right, now tell your neighbor how many blocks are needed for figure 6. All right, Renzo, how many blocks for figure 6? 6 by, yes, that is correct. 6 by 6, which is a total of what? 36 blocks. That is correct. This was 3 and 3, so what is 3 times 3? 9. 2 times 2, 4. 1 times 1, 1. All right? Send me your warm-up, please, if you haven't already. Copy the agenda. Warm-up number 37, product and quotient of rational expressions. Tonight's home plate, 8 problems only. Copy that, please. Yeah. All right, once again, warm-up number 37. We're done with that. Product and quotients of rational expressions. Product meaning multiplication, quotients, division. But today's focus, we're only going to do multiplication for the sake of slowing it down a little bit. and going step by step. And tonight's home play only 8 problems. Copy the code for your access. 46IJD. 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 Okay? All right? There wasn't any home play over the weekend. You guys, I'm pretty sure you went home, probably cleaned your house and mowed the lawn, washed some cars. And if all that was done, you probably made them some chilaquiles or something, right? Very good. Appreciate it. Show some love. And your home play for tonight, only 8 problems. Only. So, y'all ready? Get a Cornell note ready. You don't need a prayer model. All right. Our objective for today, I can multiply rational expressions. I can multiply rational expressions. I can multiply rational expressions. So if you notice, we're still on the same concept, right? Which is what? Tell your neighbor. What is still the concept that we're working on? Yes, rational expressions. And today we're multiplying. We already finished addition and subtraction. We already finished simplifying rationals. So now we're moving on to funner stuff, yeah? Yes, Missy Q. All right, here we go. Y'all ready? Caitlin, ready? Let's go. All right, rational expressions. Tell your neighbor in your own words, what are rational expressions? In your own words. Simplify it in your own words. Then Renzo's going to pass on one. Rational expressions. Renzo, pass on one. Elijah, rational expressions are? Expressions where the numerator and denominator are polynomials. That is correct. Polynomials, yes. These are not. Hashtag. There it is. There it is. All right. Gave you guys the definition for rationals. And we said that the denominator cannot be equal to 0 because of the definition. N cannot equal to 0. And that's what we call what? The excluded values. Okay? All right. So, multiplication. Look up, please. Writing utensils down. Hands off the keyboards. Look up, please. All right. Who remembers this kind of multiplication? 4 over, give me a number, 6 times 8 over, give me a number, 10. All right? We know how to multiply this, right? What is 4 times 8? 32. And what is 6 times 10? 60. Can we reduce that to lower terms? Yes. It would be 16 over 30. Can we reduce that anymore? No, right? Or yes? Yeah, which is what? 8 over 15. Okay. And so on and so forth. That's one way of doing it. Let me show you another way. 4 sixes times 8 tenths. Check this out. 4 could be 2 times 2. Is that correct? How about 6? 2 times 3. How about 8? 2 times 2 times 2. How about 10? 2 times 5. Now check this out. If I multiply going that way, I end up with 2 times 2 times 2 times 2 times 2. Denominator, we have 2 times 2 times 3 times 5. You guys see the 2's? Yes? And what do we do from there? Who remembers? Yeah, giant ones. 1, 2. What do we have left on the numerator? 2 times 2 times 2, which is? What is 3 times 5? Woo! Let's go! We got this. You're like, Q, but this is so easy. I know, let's do it with polynomials. How about them apples? Copy this. Example number 1Q. Woo-wee. So I left the steps on the right-hand side. You can copy those towards the end. But I'm going to show you the process first, and then we'll move on to, I'll give you guys some time to copy the steps. And it reads, compute the product or quotient, then simplify to lowest terms. Also identify excluded values. I want you to write the instructions, please, at least for this one, so you can have the whole thing. And it reads, 8x cubed over 6y to the 4th times 9x squared y to the 6th over 2x to the 5th. Let me send that to your screen. All right. Mario, ready? All right, Mario says we're ready. Okay, writing utensils down. Look up to the screen. You'll finish copying in a little bit. Hands off your keyboards. Here we go. Look up to the screen. I'm going to go over this one step by step myself, then I'll have you copy right after. Here it goes. Step 1. According to the steps that I gave you, it says factor completely. All right. So how do I write 8 in factored form? Well, 2 times 2 times 2. Yes? How about x cubed? X times x times x. Over. How about 6? 2 times 3. How about y to the 4th? Y times y times y times y. So far so good? Times. How about 9? 3 times 3. X squared. X times x. Y to the 6th. Y times y times y times y times y. Some of you are saying, Mr. Q, how come you didn't put multiplication in between to save space? But we know when there's two variables next to each other, it's multiplication. Next, over 2 times x times x times x times x times x. Step 1, done. Copy that, please. All right. So, step 1, we needed to factor everything. There it is. Everything's factored. Step 2, multiply numerator times numerator, denominators times denominator. So let's go to step 2. I'm going to do that in blue. So check this out. All these, basically, I rewrite them as one numerator. So I start with 2 times 2 times 2 times 3 times 3. So I'm going to write 2 times 2 times 2 times 3 times 3. Let's do this together. Then I go to the next variable. How many x's? 1, 2, 3, 4, 5. So I write x times x times x times x times x. How many y's? 6 of them. 1, 2, 3, 4, 5, 6. Bar. Let's do the same for the denominator. We got 2 times 2 times 3. How many x's? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. How many y's? 4. 1, 2, 3, 4. So, step 2, done. Step 3. I'm going to use red. It says simplify by dividing common factors or giant ones. Do you see the giant ones? Yes? Where's our first one? Gabriel, help me out. What are the x's? 1, 2, 3, 4. All the x's, okay. For the y's, 1, 2, 3, 4. So, what do we have in the numerator? What is 2 times 3? 2 times 3 is 6, and we have 2y, so that's y to the 2nd. What do we have in the denominator? Anything? So we can put that over 1, which at the end it's just 6y to the 2nd. From 1 to 5, how comfortable are you so far? How are we? 4, 4, 4, okay. Excluded values. Excluded values. Now, for addition, look up, please. We used to go with the last rational and use the denominator, right? For these, we have to go with the original denominator. So I would write what? 6y to the 4th equals to 0, and 2x to the 5th equal to 0. So question, 6 times what gives me 0? 2 times what gives me 0? 0. So what is my excluded value? 0. That is correct. I don't even need to do all the solving and such. All right? All right, send me your notes. I want to see what you did on your screen. And as you're sending me that, I'm going to send you one for you to do by yourself to over here on my screen. Example 1 super cube, very similar to the one we just did. 12a to the second over 5b to the third times 10a cubed b to the fourth over 6a to the fourth. Copy that. I'll give you some time and go. All right, here we go. For the sake of time, step 1, factor completely. 12 can be 3 times 4, and what is 4? 2 and 2, so this is 3 times 2 times 2 for the 12. Is that correct? Yes, Mr. Q. Times A over 5 times B times B times B times the 10, 2 times 5, A times A times A times B times B times B times B over 2 times 3 for 6, A, and A. Step 1, done. Step 2, multiply. That means I multiply all the numerators. Start with the 2's. 1, 2, 3. So I write 2 times 2 times 2. Then I write the 3. Then I write the 5. Next, how many A's? 1, 2, 3, 4, 5. A. How many B's? 4 of them. 1, 2, 3, 4. Over 2 times 3 times 5. 2 times 3 times 5. Then I got how many A's? 4 of them. 1, 2, 3, 4. How many B's? 3. 1, 2, 3. Step 2, done. Step 3, simplify, or giant ones. Tell me with this one, Joseph. Giant ones are 2, 5, 3, 4 A's, 1, 2, 3, 4. 3 B's, 1, 2, and 3. And what does that leave us? Let's see. We have 2 times 2, which is 4. What else do we have? 1A and 1B, so it's A, B. Do we have anything in the denominator? No, we just write it over 1, which is still 4AB. Woo! Let's go. Q, just give us a pop party already. Let's go. Hands, have you got that by yourself? All right. However, what did this say? Excluded values. So you should have written EV, 5B cubed equal to 0, 6A to the fourth equal to 0. So what is 5 times what to give me 0? 0. 6 times what gives me 0? 0. So B and A are 0. So this is 0, our excluded value. All right, tell me what you have. From 1 to 5, how comfortable are you with these? Yeah, we got this, right? All right. Let's crank it up a little bit, yeah? What do you think, Caesar? Let's go. Bam. We got 40x squared y to the fourth z to the third over 9x cubed z to the fourth times 12x cubed y to the fourth over 10x y to the sixth. Same process. Shouldn't take you long. I'll give you 1 minuto. How about that? 1 minuto? Yeah? Yeah. I didn't say minuto. I said minuto. Minute. All right, send it to your screen. Copy and go. You. All right. Let's see. Who went last? Was it Joseph? Pass them one, Joseph. Elijah. All right. Help us out, Elijah. Step 1, factor completely. What did you write for the numerator of the first one completely? Yeah, all that. What did you write for that? Factor completely. All right. He said 2 times 2 times 2 times 5 for 40. Because 2 times 2 times 2 is 8, times 5 is what? 40. Okay. And then x, x, y, 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 z, z, and z. And I know that some of you z an easier way of doing it, but for right now I'm following this process. See what I did there? See what I did there? 9. Continue, Elijah. Very good. 3 times 3. Four times the z. All right. Thank you. Pass someone. Franco. 12. You wrote it as how? Very good. 3 times 2 times 2. And then? That is correct. And the 10? 2 times 5, x, 1, 2, 3, 4, 5, 6. All right. Then from there, we go to writing all the factors on the numerator. We got 1, 2, 3, 4, 5 2s. We got 1, 3. We got 1, 5. We got 1, 2, 3, 4, 5 x's. We got 4, 8 y's. Let me make some space here. We got 1, 2, 3 z's. Over. We got 2 times 3 times 3 times 5. Then 3 x's, no, 4 x's. 1, 2, 3, 4. We got 6 y's. And we got 4 z's. So far so good? Giant ones. Help me out, Geo. Giant ones. The 5, the 3, and a 2. What else? 4 x's. 1, 2, 3, 4. 6 y's. 1, 2, 3, 4, 5, 6. 3 z's. 1, 2, 3. All right, so what do we have in the numerator? 2 times 2 times 2 times 2, which is 16. 1x, 2 y's, and that's it. 1x and 2 y's. Denominator. What do we have in the denominator? We have a 3. And what else? And a z. Hands if you got that. Let's go. You guys said that in already? All right. From 1 to 5, how comfortable are you with that so far? 4s, 5s, 5s, 4. Okay. Not bad, not bad. Shall we crank it up a little bit? You're like, Mr. Q, you haven't given us trinomials. All right. There you go. Copy that one. Example 1, super duper cube. Let's go, Mario. We got this. 4x squared y cubed over 3x squared y squared plus 9x squared, 9x y squared times x squared plus 5x plus 6 over nothing. Let me send that to your screen. All right. Now that we got the hang of the process by now, let's do this one together. Step 1, factor completely. So, what do I write for my numerator, you Lisa, for this one? If we factor it, tell me what you write. 2 times 2, x times x, y, and y. Thank you. Over, who notices that now we have a binomial here? We have a binomial, we should check for what? Standard form and then GCF. It is in standard form. What would be GCF? Tell your neighbor. Look at it. Tell your neighbor what would be our GCF. All right, looks like Rachel's got it. So with Sammy, GCF is 3x y squared. That is correct, 3xy squared. All right, so let's see. Divide that by this. That leaves us with 1x plus. Divide that by this. Notice that the x's and the y's are the same. So what is 9 divided by 3? That is only 3. Can we break up the y squared a little bit more? Yeah, y times y. Is that correct? So I'm going to put the wiggles on that. We got 3x, y, and y. Times. Look up, please, because you're going to have for hopefully one of these. Whenever you have something that does not have a fraction, always do this. Put that over 1. So, tell your neighbor how to factor this one. This one. 6 and 5. Factors of 6 that add up to 5. Tell your neighbor the factors of 6 that add up to 5. Everyone? 2 and 3 or 3 and 2. I'm going to write 2 and 3 because it looks really nice. 23. X plus 2, x plus 3. And all that over, what goes on the denominator? A 1. Yes. Step 1 done. Let's go to step 2. Multiply everything, numerators times numerators. So we have 2 times 2 times x times y, and then we have x plus 2, x plus 3, and all that over, we got 3xy, 3xy, and then we have x plus 3. Do we need to write the 1? No, right? No, Mr. Q. All right. Step 2, done. Step 3, simplify. All right? All right, Caitlin, help me out. On x, 2 y's, and x plus 3. So what does that leave us in the numerator? 4xy, parentheses, x plus 2 over 3. From 1 to 5, I'm comfortable with that? 4, 5, 4, 5, okay. 3's, 3.5, okay. And so on and so forth. Send me your notes, please. Let me send you the screen. Man, we're rocking and rolling. All right. So we get the hang of these. Just remember, if there's an expression that does not have a fraction, you write that over 1. All right? So, shall we crank it up a little bit? What do you think, Caesar? Let's go. Copy that one. Example 2. 3x squared over x squared minus 2x minus 8 times 2x squared minus 6x minus 20 over x squared minus 3x minus 10. Ooh, fire. Right. Let me send that to your screen. There it is. And I'm going to send you the screen so that when you're done, you can send that in. I'll give you a head start. Go. All right, who went last? Caitlin, pass someone so they can help me get started with this as they are doing their work of themselves. Ashlyn, all right, Ashlyn. Factor completely. How do we write the numerator, the first numerator in factored form? 3 times x times x. Very good. Next, how do we factor this? Negative 8 and negative 2. What factors of negative 8 add up to negative 2? 2 and negative 4, so my factors are x plus 2, x minus 4. Woo-wee! Not bad, not bad. Pass someone. Geo. Let's factor this one, but this one has a 2 to get started. Can we check for GCF? Which is 2. That leaves us with x squared. You know what? Let me write it, instead of writing it there, hold on. I'm going to write it over here on the side because we're going to need to factor it. 2 parentheses, x squared minus 3x minus 10. How do I factor this? What factors of negative 10 add up to negative 3? So my factors are 2 times x minus 5, x plus 2. All right, and the denominator, Geo, what are the factors of x squared minus 3x minus 10? Oh, Mario? All right, Mario. Very good. I wasn't going to pass it, but he's all Mario. All right. Woo! Look, Mario, what was this? Isn't it the same? So what are my factors? There you go. Let's go. Mario in the house. Step 1 is done. Let's multiply. Numbers times numbers, so it's 2 times 3. 2 times 3. X times x. X minus 5. X plus 2. Denominators. I just write them. X plus 2. X minus 4. X minus 5. And x plus 2. Step 2 done. Last but not least, Mayrim, simplify. Giant ones, tell us. X plus 2 and x minus 5. So that leaves us in the numerator with 6x to the second. And the denominator we're left with x plus 2, x minus 4. Hands, if you got that? Some of you, by yourself? Yeah? Okay. Send me your notes. Now check this out. Look up. Excluded values. We don't go with this. We go with which ones? The original denominator. So what would I write for that one? I would write x plus 2, x minus 4, and all that equal to 0. How about this one? X minus 5, x plus 2, and all that together, but we already have the x plus 2 here, right? So I would write x minus 4, x minus 5, x plus 2 equal to 0. Set each one equal to 0. And solve. So my excluded values are 4, 5, and negative 2. I'll stop right there. Send me your notes before you log out. Once again, get that practice in tonight, please. It's only 8 problems. Let's see how you do. And we'll continue with practice tomorrow in class. How about them apples? Pretty good? All right. Have a good one, everyone. Enjoy your home play. See you guys tomorrow. Bye.